Okay, so this is going to be the fourth video for day 12 of Unit 3 in Algebra 2. In it, we're going to talk about two theorems, the remainder and factor theorem, because they're kind of, the factor theorem is probably the more important, but it's about putting them together that really makes it all stick. Okay, so what I'm getting at here is they're not really that useful on their own. Okay, so the point is, so I'll give you a minute to pause and write down whatever you need from here. Or if you need to pause, you can do that. I guess I don't need to give you time to do that. Anyway, um, this fifth example, we're still using the same example that we've been using in previous videos. This example right here, right? So we've got a whole bunch of information from that. Okay, so our factors are 1, 2, 3, and 6. So I'm going to go ahead and write that down. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then we know from what we did in the previous video that two of those are going to be positive, one is going to be negative. So 2 will be positive, and 1 will be negative. That came from the rational root theorem and Descartes' rule. So what we're going to put into practice now is the remainder and or the factor theorem. Okay, so this basically comes down to, let's say we were doing long division and I don't know, let's just pretend that we didn't know 33 was divisible by 3. I know, that's kind of stupid, but let's pretend we didn't know that. And we know 3 goes into 33 11 times, right? So right here, that means there's no remainder. Right? No remainder means that 11 is in fact a factor of 33, but so too, obviously, is 3, right? We know that because there was no remainder, right? So when something can divide evenly into something else without there being a remainder, that of course means that it is a factor of that number. Okay, so 9 is a factor of 27 because 9 goes into 27 evenly with no remainder. So same idea here with polynomials. If we can divide a polynomial by something with no remainder, right, that means that it is a factor and we can use that to find roots. Okay, so we're going to use synthetic division and the remainder theorem to find the roots of f of x. Okay, and not really. We're going to just try to find one, because if we can reduce from a third degree down to a second degree instead, a quadratic, well, we know how to solve quadratics, but we don't know how to solve third degree polynomials like this. But if we can find one and basically reduce it to a quadratic, we can find the other two and we'll know all three of the x-intercepts. Okay, so I always like to start with the ones. Looking at this one, it just feels like x plus 1 will be a factor. And if x plus 1 is a factor, we're going to say that k is therefore equal to negative 1. Remember, this is counterintuitive, and this goes back to what we were talking about with synthetic division. We're dividing in the form x minus k. Okay, so if k is negative 1, I'm going to put my bar here, and my coefficients, 1, negative 2, negative 5, and 6. Okay, first step is to always bring that first number down. Then we multiply negative 1, negative 3, positive 3, negative 2, and then we get positive 2, and then we see that we get a remainder. Yeah, that doesn't help us any. Okay, just like what we saw earlier, we want this to be 0, but it's not. Okay, so because of that, that means x plus 1 is not a factor. Well, let's try x minus 1, and k now will be equal to positive 1. Let's try that again. So 1, negative 2, negative 5, and 6. Bring down the 1, 1, negative 1, negative 1, negative 6, negative 6. Ah, there it is. Okay, I have a remainder of 0. Or I shouldn't say remainder of 0. I should just say no remainder, right? That'd be faster. So because I have no remainder, right? This means that this is a factor, okay? So that means that x minus 1 divides into x cubed minus 2x squared minus 5x plus 6 evenly. And it reduces it from a third degree polynomial, right? So this went 3, 2, 1 constant. It reduces it to a second degree polynomial, namely x squared minus x minus 6. And if I set that equal to 0 and factor with fill in the blank, so I would have x minus 3 times x plus 2. And this looks familiar. We did this one earlier. But anyway, negative 3 times positive 2 gives me negative 6. Negative 3 combines with positive 2 to give me that negative 1, right? So that means x equals 3 and negative 2. What does this mean? Well, this means that my x-intercepts are positive 1 that I found just by luck using synthetic division, positive 1, positive 3, and negative 2. So the roots, or x-intercepts, are going to be negative 2, positive 1, and 3. And there you have it. Does that match Descartes' rule? What Descartes' rule told us? Well, yes, I have 2 positive here, okay, and 1 negative here. Okay, does that match the numbers that I had from the rational root theorem? 2, 1, and 3. 2, 1, and 3. Okay, so awesome. Now we've kind of more or less put it all together. Okay, so that does it for the remainder and factor theorems. Let me know if you have any trouble with these. Come see me in tutoring or shoot me an email. Otherwise, goodbye.